Meet Susan. Susan is a 23-year-old computer science student at the university. Today she has a semantics lecture which she is really excited about. Susan likes to get to the bottom of things, to reach understanding. She often reflects on possibilities, implications, applications, and consequences of what she's learning. Susan is characterized by a preference for deep learning. She spontaneously uses higher cognitive processes. Faced with a curriculum, she basically teaches herself. In fact, we almost cannot prevent her from learning. But she is not our concern today. Robert, on the other hand, is. Now, where is Robert? Ah, there he is. Robert is also a Homo sapiens, same age, also a student of computer science, and also has the semantics lecture today. However, Robert is a different type of student. His goal is not to achieve understanding. In fact, Robert doesn't really care about the learning in itself. His goal at university is different. His goal is to get a piece of paper and a handshake from an important man with gray hair, to pass exams, get a degree, and get a decent job. Robert is characterized by a preference for surface learning. He will only use higher cognitive processes if he really has to. He will cut any corner in achieving his goal with minimum effort.
So I'm sure that you can all see that the familiar structure of a finite automaton can easily be interpreted as a labeled transition system where the configurations simply will be the states of the automaton.
Let's have a look inside the auditorium to see how Susan and Robert are doing.
Arrow, the transition relation, will
Let's look a little closer.
Of the automaton.
This is interesting.
A bisimulation between two concurrent systems is a relation on the states, satisfying that for any two related states, if one system can perform an A action,
now let's have a look at Robert.
In such a way that the two systems end up
when is the break?
States belonging to the bisimulation. And we say that two systems are bisimilar if and only if there exists a bisimulation between the two systems. I just give you one example. If you think of a programming...
Here you might think that Robert is the only one to blame, that he's the only one responsible for his mediocre gain from the teaching. But Robert just has a different goal than Susan. He's merely responding to a system. The statistics also carry an important message and suggest a different course of action. 20 or 30 years ago, there were mostly Susans at the universities. Nowadays, however, as student intake has increased dramatically, the Roberts now outnumber the Susans. This makes for a considerable problem which is important to tackle for any responsible modern society. But before we deal with it, Robert's learning that is, we need to take a look at the situation from a different perspective.
Yes?
Excuse me, could you tell me about Susan, please?
Susan, yes, Susan is one of our good students. She always does well, not only in my own classes, but I know that she performs well in all classes. She's truly one of our good students.
Then what about Robert?
Robert.
You know, the guy...
Ah, Robert. Well, he's one of our bad students.
Notice how this labeling conveniently defers responsibility. In particular, we cannot do anything about it. It's just the way students are. So the million-dollar question is, how do we get students to learn what we want them to? More precisely, how do we get a student's activity to match our intention as a teacher?
The answer is constructive alignment. That is, to clearly state the learning objectives of the course, to make the exam measure precisely those and tell this to the students, and to choose appropriate teaching learning activities to train these skills and competences during the course.
The constructive alignment theory was developed by Professor John Biggs. Let's first have a look at an unaligned course. We have the teacher's intention, the student's activity, and the exam's assessment in play. The teacher has an intention. Let's suppose he wants the students to be able to explain, relate, prove, and apply. And now suppose the exam measures something else. For example, the ability to memorize and to describe. In this case, Robert will focus only on the skills required for the test, disregarding the teacher's intentions. This is called dealing with the test.
Of course, you can extend with as many operations as you like.
So, do we have to know about this for the exam? Okay, here's the thing. I know what they're asking, but I figure, and Jim also told me, that if I memorize the headlines and skim through the first chapters, I should be okay for the exam.
Now let's have a look at an aligned course. Here the teacher has taken great care in making the exam explicitly conform to his intentions, so that the exam now measures the ability to explain, relate, prove, and apply. Here there is no shortcut for Robert. Whatever happens, he just ends up learning what the teacher is intending.
So these are the course objectives, and also what you'll be expected to be able to do at the exam, and what my exam will measure. Furthermore, this is what we're going to reflect upon during the course, and what you'll be trained in doing during the entire course.
A level 3 teacher has a student learning focus. This is the highest level in John Biggs' 3 levels of thinking about teaching.
So now I'd like to give you 3 minutes to prepare an argument for why this aspect is syntactic and not semantic.
Now we are in a position to actually define good teaching.
Exactly, yes.
Good teaching is getting most students to use the higher level cognitive processes that the more academic students use spontaneously. Or you might say, teach so that Robert behaves like Susan.
Which is just one shorter than E.
Yeah, and then we prove it holds. Yes, that's how we do it.
You did it.